The pumps are machines that are used in the industry and quotidian life. You can see a pump in your university, in your apartment, in a factory, because the pumps is so neatly machines. The pumps are used as filtering water, boosting water pressure, and irrigating ponds and fountains. The first approximation to a centrifuge pump was a machine invented by Francesco Martini in 1475 to elevate mud. It was the first approximation to the centrifuge pump that now we know the pumps. In 1851, John Apple invented the cure find. Then, to final of 17th century, Denis Papin invented the centrifuge pump, and this is the pump that we know actually. Each centrifugal pump is made of 100 parts. There are a few components that virtually every centrifugal pump has in common. These components can be subdivided into the width end and the mechanical end. These components are designed to perform a specific task. Impeller. Impeller is a rotor used to increase the kinetic energy of the flow. Casing. The casing contains the liquid that acts as a pressure containment vessel that directs the flow of liquid in and out of the centrifugal pump. The volute is a curved funnel that increases in area as it approaches the discharge port. Shaft. The impeller is mounted on the shaft. Shaft is a mechanical component to transmitting torque from the motor to the impeller. Shaft sealing. Centrifugal pumps are provided with packing rings or mechanical seal which helps prevent the leakage of the pumped liquid. Bearings. Bearings constrain relative motion of the shaft and reduce friction between the rotation shaft and the stator. Impeller design is the most significant factor for determining performance and centrifugal pumps. A properly designed impeller optimizes flow while minimizing turbulence and maximizing efficiency. The impellers of a centrifugal pumps can be of the three basic types. Open impeller. Open impellers have the vanes free on the both sides. Open impellers are structurally weak. They are typically used in small diameter, inexpensive pumps and pumps handling suspended solids. Semi-open impeller. The vanes are free on one side and enclosed on the other. The throw adds mechanical strength. They also offer higher efficiencies than open impeller. They can be used in medium diameter pumps and with leakings contains a small amount of suspended solid. Because of minimization of recirculation and other losses, it's very important that small clearance exists between the impeller vanes and the casing. Closed impeller. The vanes are located between the two discs, all in a single casting. They are used in large pumps with high efficiencies and low recurrence net positive suction heads. The centrifugal pumps with closest impeller are the most widely used pump handling clear liquids. They rely on close clearance with rings on the impeller and on the pump casing. The closed impeller is a more complicated and expensive design not only because of the impeller but the additional wear rings our needs.
The UH curve is a curve that shows us how works the flow respect the laws that have the system. This curve always gives us for the maker and isn't the catalog. Cavitation is a phenomenon in which rapid changes of pressure in a liquid lead to the formation of small vapor piles, cavities, in place where the pressure is relatively low. When subject to higher pressure, these cavities called bubbles or voids collapse and can generate shocks wave that is strong very close to the bubble, but rapidly weaken as it propagates away from the bubble. To prevent this phenomenon, exists the in-pH curve that shows the rank where the system doesn't have cavitation. The equation to calculate the cavitation is the following, where P0 is the initial pressure, ρ is the density, Z is the height from the initial point until the pump, H is the loss, and PS is the saturation point of the liquid. The efficiency curve shows us the efficiency under one's conditions of the flow and loss. The power curve shows how many power need to take the liquid until the height that we need. The efficiency equation says the efficiency is equal to pH divided by P2, where pH is the power that the pump gives to the water and P2 is the entrance power to the shaft. Knowing the efficiency, we can calculate the power need. And the last, the system curve. The system curve is the most important curve to our analysis. This curve is the component of our system and its health and its need to choose our pump. To make the system curve, we take the energy equation and we'll leave all the terms depend of the flow and tabulate to know how is the graphic.
To the example, we have simulated that we have a requirement to transport one is the first place where the liquid, and we have to transport to the second place with a flow necessary to the system works right.